order to understand the oxygen isotope ratios, we must first understand what oxygen isotopes are. So they are basically still oxygen atoms. They both have the same number of protons and electrons, and that's what makes it oxygen. However, the neutrons are different. Oxygen 16 has 8 neutrons, while oxygen 18 has 10 neutrons, making oxygen 18 heavier.
Evaporation and condensation are the two factors that influence oxygen ratios in the ocean the most. In the beginning, oxygen 16 and oxygen 18 isotopes get evaporated. At this point, there is slightly more oxygen 16 than oxygen 18 in the atmosphere because it is lighter and easier to evaporate. When moving northward towards the poles, the heavier and easier to condense oxygen 18 will exit the atmosphere in the form of rain, and through runoff will collect in the ocean again. After these processes, and by the time the weather system reaches the poles, the atmosphere contains more oxygen 16 than oxygen 18, and the following rain or snow deposited in the ice sheets will be heavily concentrated with oxygen 16.
Glacial versus interglacial periods. During glacial periods, more oxygen 16 is stored in the ocean and the atmosphere. The oxygen 18 ratio in the ice sheets will be more negative, while the oceans will be more positive. Cooler temperatures of glacial periods causes the heavier oxygen 18 to rain out at lower latitudes and collect in the ocean, while the lighter oxygen 16 is carried farther north and condenses onto the ice. During an interglacial period, the oxygen 18 ratios are flipped. Much of the oxygen 16 is emptied into the ocean via meltwater and run off during warming.
So now we're going to talk about forems and the role they play within changing isotopic ratios and also helping to slightly predict the climate of the era. So forems are small photosynthetic organisms that form their shells or exoskeletons from calcium carbonate, which of course contains oxygen and carbon as well. And they get the oxygen from ice or from the seawater that releases water molecules, which then they take in the oxygen in the process of forming calcium carbonate, and then when they die and sink to the bottom of the ocean, they deposit their exoskeleton, which then is preserved, and then humans can then drill into the ocean sediments, and then they use those and the oxygen isotopes contained within their shells to get an accurate representation of what the oxygen isotope ratios were at the time. They can also, by the type of forem that live in the ocean, whether it be warm or cold water, tell just to a certain degree whether it was a warmer climate or a cooler climate in the ocean, anywhere where they can find forems in abundance in the ocean sediments.
As ice ages are associated with orbital variations, it follows that oxygen isotope ratios can act as proxies for some orbital cycles.